Hello everyone, welcome to my channel. In this video, we are going to discuss about a very important and interesting thing. Actually, we all know that organic compounds are mainly covalent in nature, but these bonds can acquire a partial ionic character due to some permanent or temporary effects. So here are four effects known. One is inductive effect. Number 2 is electromeric effect. Number 3 is resonance. And number 4 is hyperconjugation. Okay, so now we will discuss about inductive effect. So whenever a covalent bond is formed between two heteroatoms, like we are taking carbon and chlorine, okay. So chlorine is more electronegative compared to carbon, so it will attract the bonding electron pair towards itself, becoming negatively polarized, and this one will be positively polarized. Clear? So now if the carbon bearing the chlorine atom is attached with one carbon chain, then what happens? Suppose this one, so this one will be negative and this is positively polarized, right? So let us assume this is C1, this is C2 and this is C3. So the C1 or the positively polarized carbon atom will attract the electrons of C1 C2 bond towards itself, and this causes C2 to acquire a small amount of positive charge. So suppose this one is delta delta positive and the magnitude of this charge is less than that of delta positive, okay, and same thing happens over here also, and this one will also get a small amount of positive charge which is lesser than that of C2, and all of this happens due to the presence of chlorine atom, okay. So delta positive is greater than delta delta positive is greater than delta 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 positive, okay. So this type of bond polarization caused by the presence of this polar group or any other polar bond is known as inductive effect, okay, and this is permanent polarization of the molecule in the ground state, and this transmits throughout this chain, and this effect decreases as we move from its source, and actually this is important up to the number 2 carbon atom, okay, and actually disappears after fourth carbon atom. That's why I have not written fourth carbon atom over here. This is not that much important. But when a source of an electron releasing atom or group is attached, then what happens? Suppose we are taking lithium. So lithium is metal, this is non-metal. It is inherent tendency of a metal to become positive, so it will push electron towards carbon atom, and this one will be delta negative, and same effect will be seen but in different way. So two opposite effects we have seen over here. So two types of inductive effects are there, we can say. One is minus I effect or electron withdrawing effect. Another one is electron pushing effect or plus I effect. So now I will write names of some minus I and plus I groups. So at first I will write the names of minus I groups, okay. So they are Nr3 positive, then Sr2 positive, then NH3 positive, then nitro group, and then H2R, followed by this one greater than carboxylic acid group, greater than halogens, greater than OR, greater than OH, then AR. AR means aryl group, okay. So now I will write plus I groups also. Next COO negative, Next is R3C. R means alkyl group, that means tertiary alkyl group, followed by secondary alkyl group, then R rather than methyl group, then methyl, then D. D means deuterium. Okay. So now with the help of inductive effects, we will try to explain the properties of some compounds. Now suppose acetic acid and chloroacetic acid, we are trying to compare the acidic strength of acetic acid with chloroacetic acid. Here you can see this is alkyl group, and alkyl group is electron pushing in nature, as I have shown. So this will push electrons in this way, right? And chlorine is minus I group, so it will withdraw the electron cloud towards itself, isn't it? So acidity is all about breaking of this bond and releasing H plus ion. So anything that is present to the system which is facilitating the formation of H plus ion behaves as a good acid. Here the minus I effect of chlorine helps in that. Okay, because of the electron withdrawing nature of this chlorine, this OH bond becomes more polar in nature, and as a result it facilitates the formation of H plus ions. That is why we can say that chloroacetic acid is more acidic than that of acetic acid. Next example is fluoroacetic acid and suppose chloroacetic acid. So the minus I effect of the halogen follows the following order: fluorine, chlorine, bromine and iodine, right? So that means the electron withdrawing effect of fluorine is greater than that of chlorine, so it will attract the electron pairs more towards itself, facilitating the formation of H plus ion better in this compound. So fluoroacetic acid is most acidic among the acetic acid derivatives of halogens. Okay, and iodoacetic acid is least acidic in nature. Now suppose this one here, chloroacetic acid, dichloroacetic acid and trichloroacetic acid I have taken. So which one is most acidic? That will depend upon the number of electron withdrawing substituents. So it is said that if more number of electron withdrawing substituents are there, that will become more acidic. Why? Because in case of trichloroacetic acid, it will abstract more electron towards itself and making this OH bond more polar and facilitating the formation of H plus ions. So trichloroacetic acid is most acidic compared to these two acetic acids, followed by dichloroacetic acid and monochloroacetic acid. Next is we have to consider the positions also. Suppose this is 2-chlorobutanoic acid and this is 3-chlorobutanoic acid. Next is we are taking 4-chlorobutanoic acid. So here the position of the electron withdrawing chlorine atom is different, but the molecular formulas are same. So which one will be more acidic? That will be determined by the stability of their corresponding conjugate bases. So here the conjugate base of the first one is CH3, CH2, CH, Cl, COO negative, and this one is CH3, CH, Cl, CH2, COO negative, and this one is CH2, Cl, CH2, CH2, COO negative. Okay, so here you can see that chlorine is negative, chlorine has negative inductive effect, so it will attract the electron pairs towards them itself, so it will try to nullify the charge of this negative charge, right? But here you can see it is in the 3 position and here it is in 4 position. So they are far apart from the negative charge and cannot nullify as effectively as this one. That's why the conjugate base of 2-chlorobutanoic acid is most stable among these 3, right? So here is a rule: if the conjugate base is stable, then corresponding acid is strong. So which one will be most strong? This one. Okay. So 2-chlorobutanoic acid is most strong among these 3 derivatives of chloro derivatives of butanoic acids. So here I have written primary amine, secondary amine and tertiary amine. Okay, so I will compare the basicity of these amines. So at first I will write the electronic configuration of nitrogen. Nitrogen has the atomic number 7, so it is 1s2, 2s2, 2p, 3, right? So 3 electrons are already used up for formation of 3 bonds, one with hydrogen and 2 with methyl groups here, and here 2 with hydrogen and 1 with methyl groups over here, and here all with 3 methyl groups. So this valence shell, 3 electrons are used up for formation of bonds. So these 2 electrons will be as lone pairs. So with this lone pairs of electrons, nitrogen can act as a base. Okay. So if anything is present in these molecules which are increasing the electron density on nitrogen atom, that will behave as a good base. So here one methyl group, here 2 methyl groups and here 3 methyl groups are there. Okay. So with the increase in number of plus I groups, the electron density on the nitrogen atom will increase and they will behave as a good base. So we can say that 3 degree amine is better than 2 degree. 2 degree is better than that of 1 degree. But this observation is applicable only in case of gas phase or where hydrogen bonding is not possible. Okay. Now suppose we are taking a tertiary amine like this one, CF3, CF3, CF3. Here 3 fluorine atoms are attached with carbon. So actually this is behaving like a minus I group. So it will attract the electron density towards themselves and literally this one is not basic in nature. Okay. So in this way we can explain the properties of compounds with the help of inductive effect. So if you have any problem or any doubt regarding this topic, you can ask me in the comment section below. And if you are new to my channel, don't forget to subscribe and hit the bell icon to get notification of new videos on my YouTube channel. Thanks for watching.